So we are just continuing our notes from yesterday. So as we work today, we are going to be referencing back to yesterday's notes. So that's why I liked mine back to back. If you have to flip your page, that's okay. No worries. All right, so number 2, let's identify first what's happening in this diagram. What kind of lines are we working with? 2 secants. How do you know that they are secants? Yep, it touches the circle 2 times. So one of our segments, we have TR. Yesterday, I used orange for my secant, so I'm going to use orange again. So I have a secant TR. And I have a secant QX. Thanks. So I have 2 secants, and where do my 2 secants intersect? Are they intersecting inside, outside? Oh, I'm using the wrong colors. Orange, yellow, and green is what I'm supposed to be using. But where do these intersect? In the middle of the circle, inside. Is it in the exact middle of the circle?
We know if it is or not?
No. We're not quite sure. It doesn't have that point in the middle telling us it's circle T or circle F, and then that would be in the middle. So we need to decide which theorem or which property would we use. So which one does this one look like compared to yesterday? We are chatty today. Yeah, we're going to do the adding one, the x plus y. So let's write that down first. We're going to do the measure of angle 1, or measure of angle something. 1/2 of x plus y. Now this time, it's telling us to find what? ST. And is ST the angle? No, ST is an arc. So this ST is one of these x's or y's. So when I look at S to T, that's what I pulled blue out for. That's my part that I'm missing. So I might label that X, or you might label that Y. That's the part I'm missing. So when X here, do I have that angle that's across from that arc? Do we know that angle? That's inside the arc? Yeah, thank you. The angle inside that arc is 126. So that's going to go for our measure of angle 1. It's going to be 126 equals 1/2. Now, according to that angle, we need to use the 2 arcs across from it. What's one of the arcs across from 126? The 108, and then the other one is x. And we can put those in any order we want in this one because it's adding. So do you guys want to say 108 plus x or x plus 108? Your choice. Cool. X plus 108. Got a couple people on their phones. Put your phones away, people. Alright, and then this brings us back to algebra. Remember this trimester of geometry, we're trying to kind of get you back ready for algebra because next year, or the next course after geometry is algebra 2. So, we need to remember how to solve equations. How exciting. So we're going to draw that line down the equal sign. Our goal is to get x by itself. So there's a couple of methods we can do here. One method is to get rid of parentheses. Does anyone remember that property we can do? It goes pew, pew, pew. Does anyone remember that one? What? The property that where we take this and we multiply it by each part.
Starts with a D, I don't know.
It does start with a D. Ends in distributive. Distributive property, yeah. So we could distribute, but when we distribute, we'll still have to deal with this 1/2 because it will be with that x. So instead of distributing, we're going to get rid of that half. Now, yesterday we talked about how half is the same thing as dividing by 2. So if I think about this half as dividing by 2, what would be the inverse of divide by 2? Multiply by 2. So I can do times 2. And if I do it on one side, we do it on the other side. Multiplying by 2. How did we get there? We're trying to get rid of this half. That's our goal. We don't like that this half is sitting here. We want to get rid of it because we want to get x by it. Could distribute it, but eventually we're still going to have to get rid of that half. So since a half is the same thing as dividing by 2, to undo a half, I can also multiply by 2. It's the same idea. Good question. So if we multiply by 2 on one side, we multiply by 2 on the other. We use that handy-dandy calculator of ours. $126 times 2, and we get 252 equals. And now, this is a good question. When Yusuf asked, how did we get there? What's half of 2? 1. And do I need to write 1 times x plus 108? No. So that initially, that really undoes that 1/2 when we multiply by that. So I'm really left with what's in that parenthesis, and we're left with x plus 108. And it just makes it a little bit simpler. We could do the distributing and then solve, but that just kind of adds in an extra step when we can just get rid of that half already. So how do I get rid of a plus 108? Minus 108. And if we do it on one side? Both sides. So 252 minus 108, and we get 144 equals x. Which, if we look back at our picture, let's just double check that that's what I was asking for. That was this part here, where we put x. Is that our ST, our arc? Yep, that's where we put the x, was the arc of ST. So the measure of arc ST is 144. We do need to label it. When we measure an arc, do we measure in feet, inches, seconds, degrees, yards, months? Degrees. It's an angle. We're measuring that central angle. So kind of our key points of today is, 1, looking at your diagram and saying what you're given, where is the point of intersection, deciding what formula you're going to use, and then just solving that for x. So 3 big steps. What's in your diagram? What formula do you use? Solve for x, or whatever variable you like to use. Alright, so in our next picture, our next problem, this is our last problem today. Let's take a look at our diagram. I want everyone to take a look at it. Everyone think of your answer first. No one say it quite yet. Do we have 2 secants, 2 tangents, or do we have a secant and a tangent? Just looking, don't say it yet. Oh. Alright, let's take a look. Let's look at this SR first. If you're not sure, if you're confused, when you look at this line, SR, how do we tell the difference between a secant and a tangent? Tangents touch once, and secants touch twice. So as I look at SR, how many times does it touch the circle? 1, and it's really, it should be ray RS. So if it touches it 1 time, is that a tangent or a secant? Tangent. Yesterday I used green for my tangent, so I'm going to use green again. Alright, now as we look at ray RQ, R to Q, does that touch the circle 1 time or 2 times? 2 times. So if it touches it 2 times, that is a secant. We're not quite ready to go to our formula yet. After we identify what type of lines we're given, we then have to look at where do they intersect. Do they intersect inside the circle, on the circle, or outside the circle? Outside. At point what? Point R is where they intersect. Would it be possible for a tangent to intersect inside a circle? No, because if a tangent was going inside the circle, it would have to touch the circle 2 times. Alright, so as I look at this one, I'm going to go back to my page from yesterday, decide which formula we're going to use. So a couple of things. We're looking for a secant and a tangent, and we're looking for where they intersect outside. So which formula or which property would that look like? Yeah. We have our measure of angle A equals 1/2 of x minus y. And in this problem, there was one thing that was really important. What part of this problem do we need to remember as we work through it? That's the last one. That's where we have 2 tangents. Then they would add up to 360. This time they don't add up to 360 because it's not the whole circle. But what do we know about x? X has to be the bigger one. Why does x have to be the bigger one?
Because it wouldn't work otherwise unless we get a negative number.
Right, and do we measure angles with negatives?
No.
No, so we have to put that bigger number first. So as we take a look at this, we're looking for QTS. So Q to T to S. Is that going to be the bigger arc or the smaller arc? Bigger. So let's label that our x. Okay, if you want to write down our formula was measure of angle. And in this case, we don't have to say A. We can say R would be fine. Equals 1/2. And our formula originally was just x minus y. So we're going to fill in the parts that we know. So as I look at my picture here, what's one of the numbers I have?
71.
71. So is 71 going to go for the measure of angle R, the x, or the y? Measure of angle R. So we have 71 equals, where is this 106 going to go?
The y.
The y, good. So 1/2 times x minus 106. Once we have that set up, we're then just going to solve it. Okay, hardest part about today, or not hardest, but the big part of today is deciding which one to use. Okay, at this point that's okay. That's why we're taking time to go over it. We're going to solve for x. Our goal is to get this x all by itself. One way to think about this is who's like the best friend, who's buddies with x right now? The 106, because they're hanging out together in those parentheses. So there's 2 options. Either we can get rid of this 1/2. Okay, I like to get rid of that 1/2, but just get rid of it right away. We don't like fractions, they're gross. 1/2 is the same thing as dividing by 2. So how do we undo it? If we do it on one side, do it on the other side. Whoops. That's our property of equality. So if you ever get asked that, what property does that? To keep things equal. I don't know, someone in your life might ask you what property that is. Do you? Like when you're solving an equation in the middle of the grocery store? They're like, what property are you using? Yeah. And if you get it wrong, they laugh at you, I heard. Okay, is 142. You throw that in your calculator, but we got on a tangent, so I was trying to just give you your answer, I guess. All right, equals now 1/2 of 2 is just 1, and we don't need a 1 to multiply. So we can just write the x minus 106 there. And then all we have to do to get rid of it, to get x by itself, add what? 106. Because that's what's on the same side as that x. Using our property of equality, we do it on both sides. If adding makes you feel uncomfortable, it gives you the EBGBs, use a calculator. Otherwise, you can add using whatever method that you were taught. And we should get 248. For our final answer, though, that's labeled that nice and neat. What is that 248 actually on our diagram? QTS. So the measure of QTS, that arc, where it begins at Q, ends at S, but goes through T, is 248. We're measuring the central angle, actually, so degrees. All right, that is it for your notes.